November 18th, 1942, Guadalcanal Channel, cloudy skies over Henderson Field. The Japanese squadron commander watched the horizon with confidence. He believed that zero still reigned supreme. For 3 years, his aircraft had conquered every sky it dared to cross. Light, agile, invincible. At least that was what the manuals and the imperial doctrine said, and no one doubted the superiority of the Japanese spirit. This belief, cultivated with almost religious fervor, was about to meet its limit. Because on that day, an opponent would appear in the skies who did not respect sharp turns nor traditions of aerial dueling. The P-38 Lightning, with its twin tails and supercharged engines, climbed faster, dived deeper, and fired from afar, without asking permission. This video will reveal the technical, operational, and psychological shock caused by a machine that contradicted everything Japanese pilots believed about air combat. We will follow how a fighter rejected for its heavy and strange appearance became the embodiment of American industrial war. The story is not about an airplane. It's about the exact moment when a doctrine that valued honor and skill was destroyed by engineering, numbers, and silence at 30,000 feet. But before we dive into the data, there's one statistic that defines this story, and perhaps the very demise of an entire generation. By 1941, the Japanese Zero was king of the Pacific skies. 4 years later, more than 90% of the elite pilots who started the war were dead, shot down, or completely outclassed. Most of them without even seeing the enemy that hit them. The P-38 Lightning, dubbed by some as two planes with a single pilot, was responsible for more than 1,800 Japanese aircraft destroyed, in a quiet altitude and range campaign where dogfighting had been replaced by applied physics. And the most ironic, this same plane, initially derided by Japanese commanders as too clumsy to win, would become the largest Zero predator in the skies. If you value this type of historical reconstruction based on documents, testimonials, and technical data, consider leaving the like and subscribing. This helps us to continue rescuing the stories that explain how courage was overcome by turbo compression. November 18th, 1942. Over the choppy waters of the Guadalcanal Canal, the sky dawned grey but calm. From Henderson's Field, columns of light and constant smoke came out. Takeoffs there were no longer new. The Japanese pilots, veterans of war years in China, the Philippines and Burma, had learned to anticipate enemy movements. They knew how to recognize the low, shuffling sound of the F-4F Wildcats and the slow trace of the P-40s on the rise. But that morning, something baffled them. The sounds came first, two symmetrical roars, as if the atmosphere itself had been torn in half. Then the silhouette, elongated, with a prominent nose and two tails that reflected the diffuse light. "What kind of bomber is this?" muttered a petty officer. The instinct was to dive, gain speed, and confront, as they had done dozens of times, but the dive didn't work. Not only was the enemy already above, but it descended accurately, silently, and opened fire from a distance where Zero could not even achieve aiming stability. Within seconds, two Japanese fighters spiraled down, one of them cut in half by a direct nose blast. For the first time, the doctrine of close combat, the close turn, the dance of maneuvers, simply did not apply. The P-38 Lightning, until then an exotic presence in the Pacific theater, made its air-to-air combat debut that very day, under the command of the 339th Fighter Squadron. Escorting B-17 bombers on mission over contested territory, the Lightnings didn't just escort it, they dictated the terms of combat. With an altitude advantage of 5,000 feet, they began the attack in coordinated diving, applying the tactic that would soon become standard: boom and zoom. Diving, concentrated fire, evasion on the way up. Simple, deadly, inaccessible to Japanese pilots. No Zero in that formation could match the vertical climb of the P-38s. None reached the necessary altitude to fight back. And worse, The reaction time was practically nil. The Lightning's armament, 450 machine guns and a 20mm cannon, all fixed in the nose, eliminated the need to calculate convergence of fire. It was enough to line up and shoot. The very sound of the attack was brief and distant, drowned out by the turbocharged supercharging of the Allison V-1710 engines. By the time the Japanese pilots heard the sound, the attack had passed. The enemy was already rising again, small and unattainable. On that mission, 3 Japanese aircraft were shot down. No Lightning was lost. The tactical disparity was evident, but what the Japanese drivers did not yet know, and what would soon become evident, was that this difference was not limited to aerodynamics. It was only the visible symptom of a much larger cause. The logistical and industrial power that sustained that machine. That same month, as Japan struggled to produce about 120 Zeros, Lockheed alone had already delivered more than 160 P-38s. The United States wasn't just winning in the skies. It was multiplying that victory daily with production, spare parts, and trained pilots in record time. A statistic ignored by many Japanese commanders at the time is that by 1942, the US was already producing 47,000 aircraft engines a year, nearly 10 times the Japanese capacity. If this number surprised you, write in the comments. Logistics wins. For the Japanese drivers, however, the penny took time to drop. After the fighting, the reports sent to Rabaul were vague and often loaded with incredulity. One of them said, "The enemy rises faster than our fighters dive." Another recorded, "They appear out of nowhere and disappear into the air. Our cannons don't even reach half." Japanese combat doctrine, trained for maneuvered and heroic combat, was ineffective against an aircraft that refused to join the dance. And it wasn't just a new aircraft, it was a new air warfare mentality. While the Japanese valued combat between individuals, the pilot as a hero, the Americans already saw the pilot as the operator of a system. Lightning was just the vector of a larger set. Intelligence, radio communication, coordination with bombers, mutual coverage in pairs. The Zero still represented the 1937 war. The P-38 was already the harbinger of 1945. That morning over Guadalcanal, the sky turned sideways. The top of the fight, until then, Japanese, became American. And when you lose the top, you lose everything. The initiative, the time, the choice. The Lightnings didn't ask for combat. They did. And when they wanted, they disappeared. But that was only the first impact. Because what the Japanese faced that day was only the visible tip of a much larger machine. What would come next would not only be a change in performance in combat, but a brutal rewriting of what it meant to dominate the skies. In the next part, the Japanese doctrine will be put under analysis, and we'll see how, in designing the Zero, Japan built the perfect plane for a war that no longer existed. To understand the shock that Japanese pilots experienced when facing the P-38, one must first understand what they believed. The Mitsubishi A6M-0 wasn't just a war machine, it was the embodiment of a doctrine. A philosophy of combat built not on data, but on honor, tradition, and the conviction that air warfare would be decided by the individual skill of the pilot. Light, fast, and incredibly maneuverable, the Zero was conceived as an almost spiritual extension of the Japanese warrior. Every screw, every design choice reflected that belief. To achieve the desired performance, Japanese engineering sacrificed armor, self-sealing fuel tanks, mechanical redundancies, and even modern communication systems. All in the name of lightness and consequently agility. The doctrine said, if the pilot is good enough, he will never be hit. That premise worked for a while. During the first 2 years of the war, the Zero reigned supreme against outdated British fighters, unprepared colonial air forces, and adversaries who insisted on confronting it on their own ground. The maneuvered dogfight. It was in China that the plane earned its reputation. Against the old-fashioned Soviet I-15 and I-16, the Zero flew like a ghost. And in the early Pacific, facing off against the Brewster Buffalo and the first-generation P-40s, the legend grew. But every legend is fueled by a context, and the context was changing. Japanese doctrine ignored a growing variable, the accelerated industrialization of air warfare. Imperial Navy engineers knew of the existence of sealant tanks, cockpit armor, and more powerful engines, but deliberately rejected them. What the Americans called superfood, the Japanese considered dead weight. What the Americans treated as a survival statistic, the Japanese saw as a deviation from the purity of combat. While the United States designed fighters with operational margins of error, armor to miss, power to escape, concentrated armament to minimize exposure time, the Japanese designed for the duel. The Zero was the end product of an almost romantic concept, the idealized, lonely, agile pilot facing the enemy face to face. And so, on paper, the plane seemed unbeatable. It flew for more than 2,000 kilometers, cornered at absurd speeds, and weighed almost half as much as American fighters of the same generation. But real war does not respect paper. In practice, the absence of protection made Zero a flying coffin in the face of incendiary projectiles. Their tanks exploded at the slightest impact. Its lightweight aluminum frame warped under stress, and above 6,000 meters, its Nakajima Sakai engine lost power dramatically. The pilot, no matter how trained, was only human in the face of these physical limitations. The doctrine said, avoid being hit. Reality said, you will be. The Japanese operational culture reinforced this abyss. Pilots were trained to operate in silence. Radio communication was limited, often non-existent. Coordination between formations was rudimentary. Individual initiative was valued to the detriment of coordinated action. And while this allowed for feats of courage and improvisation, it proved disastrous against enemies who operated as organized swarms, with mutual cover and altitude superiority. In the command centers, senior officers held the unshakable belief that the human factor would prevail. When the first reports came in about twin-engine American fighters rising faster than anything ever seen, the answer was not to reformulate doctrine, it was to doubt the reports. When engineers suggested changes to Zero's design, including structural reinforcements and survivability systems, the requests were denied. The order was clear: maintain performance and lightness. Adapting would mean admitting that the spirit alone was not enough, and that was inconceivable. The historical irony deepened. Japan had built the ideal fighter for the War of 1937, but in 1942 the war was different. The war now involved intercepts at 30,000 feet, dives at 500 miles per hour, radar, escorts, fuel consumption calculations on transoceanic missions. The battlefield had changed, and Zero, which seemed to fly with the lightness of a leaf, now showed itself vulnerable as paper. Meanwhile, on the other side of the Pacific, American factories were already preparing field modifications to the P-38s based on the first clashes. More shielding, more power, better cooling. Pilots received weekly instruction based on actual combat footage. Japanese aviation, in turn, maintained its liturgy, the same exercises, the same formations, the same certainty that the spirit would overcome the machine. But the machine, as they would soon see, did not respect faith. It operated on the basis of physics, atmospheric pressure, and metallurgy. It rose when Zero stagnated. She dived when Zero trembled. It absorbed damage when Zero exploded. And most of all, it didn't have to be heroic. It just needed to work. In the next part, the focus will shift to the creation of the P-38 Lightning itself. An aircraft that was born not from a warrior ideal, but from a spreadsheet of technical requirements issued by the United States Department of War. Because while Japan designed heroes with wings, America engineered the impossible. And against that, courage would not be enough. In 1937, while Japanese engineers were discussing how to further reduce the weight of the Zero, a young Lockheed engineer named Kelly Johnson proposed something radically different: a high-altitude, twin-engine, turbocharged fighter with a long range and a top speed of over 400 miles per hour. It was a proposal that seemed absurd by the standards of the time. Until then, fighters were designed to be small, light, and cheap. Johnson, however, believed that the future of air warfare would require interceptors capable of covering great distances, climbing faster than any bomber, and attacking with concentrated power. This is how the technical specification of what would become the P-38 Lightning was born, a plane designed to intercept, hunt, and escape, operating at the edges of known physics. The project was approved in January 1939. Just 143 days later, the first XP-38 prototype made its maiden flight, a speed of development that reflected not only the technical enthusiasm but the industrial capability of a country that had not yet entered the war. Its fuselage was revolutionary. Two long bodies connected by a central section. Each body housed a supercharged Allison V1710 engine with a General Electric turbocharger, a solution that allowed the Lightning to maintain maximum power even above 7,000 meters of altitude. This was an overwhelming advantage against conventional fighters that quickly lost performance in thin air. With centralized armament, 4 50 machine guns and a 20mm Hispano cannon, the Lightning eliminated one of the most common problems of fighters at the time: the convergence of fire. By concentrating all weapons in the nose, the P-38 fired with millimeter precision, without relying on complex angle or distance calculations. The philosophy was clear. Combat would no longer be decided by acrobatics, but by science. But his true secret weapon was not visible. It was reach. With full tanks, the P-38 could fly more than 3,000 kilometers, twice as much as single-engine fighters at the time. This allowed for operations over distant islands, in-depth escort missions, and tactical intercepts without the constant need for refueling or forward bases. While the Zeros relied on aircraft carriers or makeshift runways near the front, the Lightning arrived, attacked, and returned. During testing, however, the plane faced a problem that nearly compromised its future: aerodynamic compressibility. When reaching high speeds in diving, the air behaved unsteadily around the wings, causing the controls to lose effectiveness, an issue still poorly understood by engineering at the time. Lockheed, however, did not back down. Instead, it installed compensatory airfoils, reinforced the structure, altered the stabilizer, and adjusted the control surface. The result was a fighter that dived faster than any other in the Allied arsenal, often exceeding 800 km/h. In Europe, the British refused Lightning. They considered it too big, too expensive, too complex. The Germans, for their part, completely underestimated him. They called it a propaganda aircraft and assumed that no twin engine could compete with the agile single-engine Luftwaffe. The mistake would be fatal. Meanwhile, Americans understood the Lightning's true role. It wasn't a dogfight fighter. It was a strategic interception system. In the skies of the Pacific, this would become evident. Its performance at altitude allowed it to surprise the Zeros from above. Its diving speed eliminated any attempt at pursuit. And its reach redefined the operational limits of air warfare. Behind this performance was a production machine capable of manufacturing, adjusting, and distributing components with unprecedented speed. Lockheed alone produced more than 10,000 units of the P-38 between 1941 and 1945. Each unit received field upgrades based on combat data, recalibrated armament, new electrical systems, cooling improvements. It was a living aircraft, constantly evolving. What's more, it was standardized. What was learned on Guadalcanal was applied to Luzon, then to Iwo Jima. In the field, American pilots who were initially suspicious of the P-38's eccentric appearance soon realized its value. By flying above the battle theater with full view of the enemy and the ability to decide when to enter and leave combat, Lightning operators didn't just win, they controlled it. Reports from Japanese pilots indicated a recurring feeling: powerlessness. Even when they saw the lightning, they knew they couldn't reach it. When they heard its roar, they were already being hunted. It was with the P-38 that the American air doctrine abandoned maneuvered combat once and for all and adopted boom and zoom as an official tactic. Attack from above, run up, decide when to fight. And in this environment, Zero, with all its lightness, became a static target. The irony was cruel. The plane that was ridiculed for looking slow and heavy now flew faster, climbed higher, and decided the rules. But the true impact of the P-38 was yet to come. Soon, that same aircraft would be tasked with the most daring mission in the Pacific theater, finding and shooting down the architect of the attack on Pearl Harbor. In the next part, we'll look at how the Lightning's technical superiority allowed for something that no Japanese pilot ever thought possible: assassinating an admiral in mid-flight, 1,000 miles offshore, with surgical precision and without giving him a chance to react. Air warfare has always been a three-dimensional contest, but on Guadalcanal, from the end of 1942, this dispute was no longer balanced. While Japanese fighters still flew as masters of horizontal spinning, the Americans had come to master what really decided modern combat: altitude. The P-38 Lightning was designed to operate in layers of the sky that Japanese pilots could not even sustain. With its Allison twin engines equipped with General Electric turbochargers, the Lightning maintained full power at 9,000 meters high, while the Zero, with a naturally aspirated engine, lost torque as early as 6,000. In practice, this created an irreversible scenario. American pilots saw the Japanese from above, and the Japanese, they just saw. The fight is no longer a duel. It became a sentence. Lightning chose the moment. It dived in silence, fired accurately, and disappeared in a low climb. Evasion attempts were futile. The Zero, with its lightweight frame and lack of compression, stagnated. Neither speed to flee nor power to climb. The fighter that he once dominated with maneuvers now died without an answer. Saburo Sakai, one of Japan's greatest aces, summed up the sentiment in a cutting phrase: "We could no longer reach the enemy." It was more than a technical fact. It was the confession of the beginning of mental defeat. The effect of this on Japanese aviation morale was devastating. The training, based on direct confrontation, became irrelevant. The battles ceased to be battles and became aerial ambushes. The American driver saw everything. The Japanese driver only realized the attack when it was too late. The Lightning, with its altitude and diving advantage, imposed a new geometry of warfare, from top to bottom, from silence to impact, from the invisible to the irretrievable. While Japanese engineers tried unsuccessfully to adapt the Zero to these new requirements, the Americans were already working on standardizing tactical manuals based on data collected by cameras installed on the P-38. Each combat film generated instructions, each agreement became protocol, and each failure was corrected with technical and logistical adjustments in real time. The Zero not only had no cameras, it didn't even have an armored cockpit, and often not even a functional radio. It was like comparing a ceremonial bow to a guided missile. The irony of this story is that the solution was in front of them. Japan had the resources to develop more powerful engines and improve performance at altitude. But the doctrine was rigid, and pride greater than physics. While the Americans saw altitude as a strategic advantage, the Japanese continued to treat it as an obstacle. In his view, the ideal combat was still tactical turning, not vertical pursuit. If you are enjoying unraveling these facts with depth and accuracy, show your support. Like and subscribe so that we can continue to bring these analyses with the respect and rigor that the story deserves. What started as an engineering gap soon turned into an operational moat. By 1943, combat records showed that for every P-38 lost, at least 5 Zeros were shot down, not for greater courage, but for better altitude, better physics, better logistics. A Japanese officer reviewing the reports of the air unit in the Pacific wrote in a tone of despair, "They attack from above, always. We have no answer. Our best men fall without even seeing where the shot came from." And the data doesn't lie. In less than 6 months, Japan's once undisputed air superiority was dismantled, not by number of aircraft, but by performance. The doctrine of the Spirit was forced to face a new god, the operational altitude, and against it, there was no longer any prayer that worked. In the next part, the impact of this disparity will become even clearer, because when Japan lost altitude, it lost its aces, and with them, he lost the only weapon he could not manufacture in series: experience. We'll see how the P-38 became the hunter of an entire generation, and how it quietly sealed the fate of the empire. Air warfare, for the Japanese pilot, always began with sound. A distant roar, the crescendo of radial engines, the crackling of gusts. All this was part of the anticipation of combat, but the arrival of the P-38 changed this sensory ritual definitively. With its engines supercharged by General Electric turbochargers, the Lightning produced a muffled, low-pitched, unusual sound, almost always inaudible until the last second. Flying at high altitude, diving at supersonic speeds for the time, and slowing down on approach, the P-38 transformed the air battlefield into a place where silence preceded death. To the Japanese pilots, it was as if the sky itself had turned against them, an invisible predator that chose the time to strike and attacked without warning. The accounts recorded in post-war diaries and interrogations of captured officers reveal an alarming change in the psychological behavior of Japanese air units. Some pilots turned down missions after weeks of unsuccessful sorties against the ghost fighters. Others reported attacks coming without sound, without shadow, without warning. The feeling was that of being watched by something that one could not see, let alone reach. The battlefield, which had previously been dominated by aggressiveness and maneuvering, became a territory of anticipation and anxiety. It was no longer a war of encounters, it was a war of invisible ambushes. Lightning's structure favored this type of attack. Its tapered nose, long wings, and aerodynamic profile designed for diving stability made it a machine that integrated into its surroundings. At altitudes above 8,000 meters, where Japanese radars were inefficient and naked-eye vision was limited, the P-38 operated with complete freedom, and when he decided to dive, he did so with angles greater than 60 degrees, exceeding 800 km/h. In practice, the Japanese pilot only noticed the attack when the shots had already passed, or when the instruments were already shaking in despair. This effect was amplified by the cultural context. The Japanese pilot was trained to be the hunter, not the prey. His doctrine said that the enemy would always appear from the front, ready for confrontation. But now the attack was coming from above, without warning, and from a distance where neither the machine guns nor the eyes could react. The terror didn't just come from the technical impact, it came from the psychological inversion. The hunt had changed sides. At the forward bases in the Pacific, especially at Rabaul and Truk, the first rumors arose among Japanese soldiers. Lightning has no shadow. The two-tailed demon. The sound that kills without sounding. These expressions, although they seemed exaggerated, had a technical basis. The noise of the V-1710 engines, softened by the design of the exhaust fans and the compression at altitude, caused the P-38 to approach like a whisper, imperceptible until it was too late. American pilots reported that on many occasions the Zeros continued to fly in a straight line even after their comrades had already been shot down, not because of courage, but because they didn't know they were under attack. American intelligence noticed this effect and began to use it as a tactical resource. P-38 patrols operated in pairs or quartets, alternating altitude and direction to confuse enemy lookouts. On night missions, they covered the sky with infrared flashlights, tracked by ambient sound, and disappeared before they were even identified. It was the beginning of what is now called sensory spectrum domain. Japan, stuck in the vision of visual warfare, had no way to react. Their fighters had no radar. Its pilots did not practice blind flights. The combat ceased to be physical and became sensorial. And on this new battlefield, Zero was blind and deaf. The side effect was devastating. Fear began to set in before the first shot. The low, distant sound of lightning's motors, sometimes mistaken for the roar of thunderstorms, has become synonymous with imminent death. Pilots slept less. Ground crews hid the aircraft even at supposedly secure bases. The mere suspicion that a P-38 had been spotted at altitude caused entire units to abort missions. Worse, those who tried to fight back often did so with tactics that no longer worked. Frontal climbs, horizontal turns, circular combat. Against an enemy who had already chosen the time to leave, these answers were not only useless, they were suicidal. In the February 1943 report, the Japanese Air Command in Bougainville recorded a symbolic fact. In 1 week, 27 hostile aircraft were detected at altitude. Only 3 could be engaged. None were shot down. The rest simply disappeared. It was the beginning of what American analysts called a war of denial of air presence. The P-38 didn't just kill. He prevented the enemy from operating. Behind the scenes, the irony was blatant. The plane that many generals had dismissed as too big to hunt now became the invisible predator of an empire that prided itself on its ability to see first, strike first, and win with spirit. Lightning didn't give the chance at the first look. In the next part, we'll look at how this silent machine was used for something even more daring, an aerial assassination. An unprecedented mission that would combine deciphered intelligence, precision flight, and the deadly logic of the P-38 to shoot down Japan's most protected man in mid-flight. His name was Yamamoto, and his death would be orchestrated by an invisible equation. The first sign of collapse did not come from the trenches or the hangars. It came from paper. In January 1943, a classified document was quietly circulated among the squadron commands stationed at Rabaul, the largest Japanese airbase in the South Pacific. Written by the intelligence of the Imperial Navy after a series of combats with the P-38 Lightning, the report brought a conclusion that sounded like heresy to the indoctrinated ears of Japanese aviation. The enemy has technical, energy, and altitude superiority. The P-38 aircraft should be avoided in direct combat, except in situations of absolute numerical advantage. The sentence was short, precise, and devastating. It was not just an operational evaluation. It was the formal negation of a code that underpinned an entire war mentality. For the first time, the doctrine of combat as an expression of individual honor was disallowed. Officially, the impact was immediate. The report, although confidential, did not take long to echo through the corridors of the air units. For many young riders, it represented a secret relief. They already knew from bitter experience that the Lightning couldn't be beaten in the spin. His evasive maneuvers failed. His attempts at climbing were outclassed. But now there was an order, a strategic logic, a permission to survive. For others, especially veterans trained in the Sino-Japanese War, the feeling was one of betrayal. One of the instructors in Rabaul reportedly tore up the report in front of his class, shouting, "If we can't face the enemy head-on, why are we here?" But mathematics was more ruthless than ideology. The average direct combat losses against P-38s exceeded 5 to 1. Most engagements took place out of visual range, with lightning dictating distance, angle, and time to attack. What's more, even when a Japanese driver managed to line up a defensive maneuver, the lightning escaped vertically, using its two engines and reinforced structure to climb where the Zero stagnated. It was no longer a question of courage. It was applied physics. The report also detailed for the first time the analysis of the weapons. It was noted that the Lightning's 20mm cannon, mounted in the nose and accompanied by 4.50 machine guns, allowed a concentrated burst of very high destructive power, effective even at great distances. Unlike Japanese fighters, which relied on short firing windows at extreme range, the Lightning shot down its targets with rapid, frontal fire, often before the enemy pilot identified the threat. It was the practical application of American doctrine: maximize the useful time of attack and minimize the risk. Every second counted, and every second belonged to Lightning. The document described, with a technical and impersonal tone, what the pilots already felt in the air. They were being beaten by a machine that did not follow the rules, that he did not accept duels, that operated on a plane of reality where honor was irrelevant and the result inevitable. But the most symbolic point came at the end of the report, almost like a whisper. Avoiding direct confrontations should be interpreted as a tactical preservation measure, not as weakness. For a military culture based on the cult of sacrifice, this was a philosophical rupture. In the following weeks, cases began to emerge of entire squadrons changing patrol routes when they detected the presence of P-38s. Escort missions were cancelled. Combat groups called for reinforcements before taking off. It was not cowardice, it was adaptation. The ideal of the samurai warrior was being eroded by the reality of industrial warfare, where survival and effectiveness outweighed glory. The new doctrine was clear: choose the battles you can win, and against Lightning, almost none fit this condition. At Rabaul headquarters, there were attempts to reformulate the discourse. Propaganda officials suggested classifying Lightning as a priority threat, encouraging alternative tactics. But none worked. They tried the attack in closed formation. The Lightning shot down the leader and went up. They tried synchronized diving. Lightning would come from above and dismantle the geometry. They attempted low-altitude ambushes. The Lightning, with superior range, simply avoided it. It was like trying to catch the wind with fishing nets. Meanwhile, on the other side of the Pacific, the Americans had already processed hundreds of hours of combat footage captured by cameras in the nose of the P-38s. Each engagement was analyzed, modeled, transformed into statistics. The next generation of pilots arrived at the front, already knowing what to do against Zero. The Japanese, on the other hand, stuck in the 1937 doctrine, saw their aces fall, and with them, the only differential they still had: experience. The cultural collapse was consolidated with each mission. There was no longer any discussion about who would win. There was discussion about how to avoid losing more. The ideology of sacrifice, once the mainstay of the Japanese air war, was now a pointless sentence. And the P-38, more than an airplane, was the symbol of this new war. Impersonal, invisible, unstoppable. In the next part, we'll look at how this erosion of values culminated in the most symbolic loss of Japanese aviation, and how Lightning was the instrument of an execution that would forever change the way Japan viewed the sky. Because when even the architect of war is shot down by a silent machine, the empire understands that neither honor nor tradition can fly higher than engineering. By the time the skies of the Pacific became the new decisive front in the war, Japan realized that its once feared air force had become obsolete, not for lack of courage, nor for lack of doctrine, but for something more ruthless: the industry. The P-38 Lightning wasn't just a fighter, it was the embodiment of a system that Japan couldn't replicate. And when he tried, his hands were empty, literally. The hangars lacked raw materials, the research centers suffered from bombings, the engineers worked without copper, without treated steel, without ready engines. Each attempt at an answer became, in fact, the portrait of an empire cornered by its own structural limitation. In 1943, the Japanese accelerated the development of prototypes that could match the P-38. The most promising was the Kawasaki Ki-102, a heavy twin-engine fighter with ambitions for altitude superiority. But the project faced a fundamental obstacle: the engine. Japan did not master the manufacture of reliable turbochargers. Its twin-engine engines, even when well-designed, lost power at critical altitudes. The Ki-102 itself, which performed well in low-altitude tests, became unstable above 6,000 meters. What the Americans called the combat plateau, the Japanese called the structural limit. The reality was harsh. In 1943, while the United States produced more than 85,000 military aircraft in a single year, Japan barely exceeded 16,000. The difference in scale was so great that Japanese units began to receive fighters without spare parts, and in some cases without paint to save materials. The squadrons needed to cannibalize damaged aircraft to keep the others in operation, and the average lifespan of a new Zero on the front lines fell month by month. One piece of data reveals this collapse in a crystal-clear way. While the P-38 was produced on mechanized lines with standardized processes, Japan still depended to a large extent on manual assembly and decentralized production. There was no capacity to replicate complex models on a large scale. Japanese engineers knew what they needed, but they had no way to make it. There was a lack of metal alloys, rubber seals, precision electric welding. And even when they did get promising prototypes, they didn't have the logistics to test them in real combat conditions. Some projects have made it to the skies. The Nakajima Ki-84, for example, demonstrated good performance and effective weaponry. But its engine, the Homar, had a critical failure rate of more than 40%. With no spare parts, no high-octane jet fuel, and with increasingly inexperienced pilots, the plane never reached its projected potential. It was like building a saber and handing it to an apprentice with no training, against an enemy with automatic rifles and unlimited supply. And the worst was yet to come. The lack of turbocharged engines prevented Japan from designing any fighter that operated on par with the P-38. Without compressed oxygen for high altitude, without advanced cooling systems, the new Japanese fighters were still stuck in the reality of 1940, while the Americans were already thinking about pressurized planes, onboard radars, and long-range missions. Here it is worth pausing for an astonishing fact. By 1943, the United States had produced more aircraft engines than Japan had produced combat aircraft in the entire war. A single model, the Allison V-1710, used in the P-38, had more than 60,000 units manufactured. That's right, an American engine model had almost 4 times the total production of Japanese fighters. If this number surprised you, write in the comments, "Logistics wins." Because that was the secret. It wasn't just about having one good aircraft, it was about having 1,000 good aircraft, all working, all adapted, all fueled. In Japan, this scale was impossible. Production was fragmented, vulnerable to bombing, and lacking strategic raw materials such as aluminum, rubber, and magnesium. And what was produced arrived late. By 1944, some units received new fighters without an operating manual. Pilots learned to fly by trial and died without knowing the full power of the engine they used. Attempts to mimic the P-38 failed one by one. The Mitsubishi J2M Raiden, designed as an interceptor, had limited performance and almost zero rear visibility. The Nakajima J5N Tenrai, twin-engine and promising, was cancelled before entering combat. The Ki-102 itself, in its most advanced version, has only flown in secondary operations. None of them managed to change the course of the war. They were all victims of the same invisible enemy, the American production chain. In the command centers of the Japanese General Staff, frustration gave way to silence. There was no longer any discussion about which model would replace Zero. There was discussion about how to keep those who were still flying. Japanese aviation was no longer an offensive force. It became defensive, fragmented, increasingly dependent on desperate measures, such as suicide hunts or attempted night ambushes. None of this would solve the fundamental problem. The P-38 was still there, climbing, diving, deciding when to fight. In the next part, the abyss will become even more evident. Because while Japan was still trying to build prototypes, the United States was using Lightning to execute the most accurate aerial assassination mission of World War II. And she succeeded. The empire that could not climb now lost even the right to dream of the counterattack. The art of aerial combat, once defined by perfect turns and sky-night clashes, had been rewritten by a new playbook, cold, mathematical, and impersonal. At the heart of this tactical revolution was the concept of boom and zoom, diving from higher altitude at very high speed, attacking with precision, and escaping before the enemy had time to react. It was a simple maneuver in theory, but devastating in practice. And the P-38 Lightning, with its twin engines, reinforced fuselage, and concentrated armament, had been tailor-made for it. While the Japanese still dreamed of the aerial duel in tight turns, the Americans had already understood that the sky was a plane of opportunity, not honor. The boom and zoom worked as a vertical ambush. The American pilot maintained a higher altitude, scanned the space ahead, and when he identified a target, usually a Zero or an unprotected bomber, he began diving. The attack was coming at more than 700 km/h, with full power and gravity advantage. The shot was single, concentrated, with the aim stabilized thanks to the Lightning's fixed nose. The gust, when it hit, was definitive, and before the target or its allies could counterattack, the Lightning had already resumed altitude, accelerating on the climb with its Allison engines in afterburner. It was a tactic based on three principles: energy, initiative, and evasion. And all of them contradicted what the Japanese manuals taught. Meanwhile, the Japanese pilot remained stuck in the dogma of maneuverability. His training was focused on coordinated turns, circular approaches, and mastery of the field of side vision. In duels against other Zeros or against less powerful aircraft, this style worked, but against boom and zoom, it was useless. The attack came from outside the visual field. The curve didn't have time to form. The combat did not begin. It was already over. The Japanese doctrine, based on individual excellence, did not prepare pilots for the new reality. The sky, once a stage of skill, became a theater of physics. And in this new language, those who dominated the energy, not the spin, dominated the war. American formations were trained to maintain altitude, conserve speed, and pick engagements. The Japanese, on the other hand, sought eye contact, direct confrontation. They were incompatible styles, and the result was predictable. U.S. Air Force documents from 1943 detail how boom and zoom became the standard of engagement on P-38s. Each pilot was trained to avoid horizontal turns, maintain an energy advantage, and operate as an air sniper. The manuals clearly stated, "Do not pursue, attack, and climb." And this pattern worked with impressive effectiveness. Slaughter rates have increased, losses have decreased, and the air dominance began to be consolidated not by quantity, but by geometry. The psychological impact on the Japanese was profound. They did not understand how they were being defeated without even engaging in combat. On patrol missions, the silence was interrupted by sudden bursts. Within seconds, a companion would burst into flames, and the enemy would disappear into the sky above. There was no room for reaction. There was no tactical logic within the traditional doctrine. Some officers even described the new air war as illogical, but it was not illogical. It was just another logic. Boom and Zoom didn't just redefine combat, he redefined the concept of air superiority. He was no longer the one who maneuvered better, he became the one who chose when and how to fight. And the P-38, with its range, power and robustness, was the ideal platform for this philosophy. Against him, Zero was like a swordsman facing a long-range rifle, elegant, accurate, but doomed to defeat by the simple difference in range and initiative. And here is a cruel irony. Japanese commanders knew of the existence of this new tactic. They knew the concept of energy in combat. They even knew that their pilots were being shot down before they got into position. But the doctrinal structure, rigid and conservative, did not allow for rapid changes. Reversing the training of hundreds of pilots, replacing an entire culture based on courage with a cold logic of applied physics, it was simply unthinkable. And it was this doctrinal hesitation that sealed the fate of many. The P-38 was not invincible, but in the right hand with higher altitude and using the boom and zoom, it became unattainable. A predator that attacked without warning and disappeared without a trace. Air warfare had ceased to be art. It had become science. And Japan, stuck with art, was being crushed by statistics. In the next part, we'll look at the pinnacle of this new era, an operation of absolute precision where boom and zoom would be used not only to hunt down aircraft, but to eliminate the strategic brains of the Imperial Navy, the attack on Isoroku Yamamoto, a plan that could only be executed by an airplane that won not only by strength, but by range, altitude, and mastery of physics. The myth of heaven belonged to Zero. Since Pearl Harbor, Japan had built its aura of invincibility on thin wings, elegant curves, and the heroic image of pilots who won by will. The propaganda extolled the spirit of the modern samurai, disciplined, agile, willing to die for the homeland, and piloting the perfect machine. For months this myth remained intact. But when the P-38 Lightning began to appear in the skies of the Pacific, something broke, and it wasn't just the hull of the planes. It was the image that Japan had of itself. The first letters from the surviving pilots described a new, disconcerting sensation that did not fit in the manuals of honor: impotence. A sergeant of the 582nd Kokutai wrote to his brother, in a restrained tone, that the enemy now appears out of nowhere and disappears without a choice. Another, a veteran officer who had fought over China, wrote in his diary, "It's like fighting the wind. He feels it when we want to face it and disappears. But when we don't expect it, it descends like the blade of a sickle." Words like that did not circulate in public. But in the conversations about accommodation, in the looks at the end of the missions, it was clear heaven was no longer theirs. The blow was deeper because of doctrine. The Zero had been designed and sold to the Japanese soul as an extension of the warrior. Light, responsive, unshielded. Every engineering choice was also an ideological gesture. Such was the confidence that training manuals did not emphasize evasion, vertical combat, or long-range shooting. Because Zero was seen as absolute in direct combat, all it took was skill. But now there was an enemy who didn't play for the same book, a fighter that ignored turns, avoided dogfights, and killed before it was even seen. Younger pilots, newly arrived at the front, received contradictory instructions. Officially, they were to maintain doctrinal standards. But in practice, its leaders recommended avoiding engagements whenever the enemy was at a higher altitude, which almost always meant avoiding combat. Many did not understand. How could the best fighter in the world be inferior? The answer did not come from superiors, it came from statistics. In squadrons that engaged P-38s regularly, survival rates dropped to less than 30% per mission. One of the most symbolic accounts comes from a lieutenant who survived 3 sorties against American formations and was transferred for training. During a post-war interview, he confessed, "It wasn't fear, it was certainty. When we saw the 2 silver streaks up there, we knew that one of us would not come back, and we knew there was nothing we could do. This feeling, that the enemy decided the time of combat, not you, eroded the emotional foundation of Japanese aviation. War for them had always been an initiative. Now it was a reaction. This moral transformation impacted discipline, spirit, and the very concept of mission. Pilots who used to compete for flights started to avoid stopovers. The silence at the briefings increased. The glances exchanged in the hangars revealed more than words. And among the veterans, a quiet anguish was growing. How to teach the newcomers a doctrine that no longer worked. How to train a generation to fight against what cannot be faced. The propaganda tried to maintain the heroic narrative. Posters extolled victories, distorted reports, and hid losses, but the pilots knew they were there. They knew that the sound of the P-38 did not come with music, that the blasts that tore through the sky came from afar, cold, lethal, and that Zero, glorified for years as the ultimate predator, was now just prey, brave but vulnerable. The greatest trauma was perhaps internal. For a Japanese warrior, admitting inferiority was not only uncomfortable, it was shameful. Many have chosen silence, others for sacrifice, even if in missions without strategic value. The code of honor that sustained morality became a prison, and defeat, even before the fall of the empire, already inhabited the hearts of those who took flight. By the end of 1943, the units that had previously led the air war were in psychological collapse. The average flight hours of pilots in combat dropped. The ability to coordinate between training has been reduced, and in flight schools, instructors already avoided mentioning the P-38s. It was as if naming them from this body to fear, as if admitting what was happening in the sky weakened what still resisted on the ground. And meanwhile, on the American side, the data was celebrated with industrial precision. The effectiveness of boom and zoom was measured in statistics. Each mission was analyzed, each kill documented, and the P-38 continued to grow in reputation. Now, it wasn't just the long-range fighter, it was the symbol of a war won, even before combat. By altitude, by science, by initiative. In the next part, the war will become personal. Because the machine that destroyed the myth of Zero will now be used to slaughter the one who created it. The most daring mission of American intelligence was about to be executed, to intercept and eliminate Isoroku Yamamoto, the strategic brain of the Imperial Navy, in the middle of the Pacific. And what seemed impossible, it would be solved by calculations, altitude, and the invisible radius of 2 silver tails. At 9:34 a.m., on April 18th, 1943, over the sweltering jungles of the island of Bougainville, one man's plane crashed, and with it, an entire doctrine. Inside the Mitsubishi G4M Betty, escorted by 6 Zeros, was Admiral Isoroku Yamamoto, architect of the attack on Pearl Harbor, the ultimate symbol of Japanese naval strategy. But at that moment, the sky was no longer Japanese. He was American. And above the horizon, operating at the extreme limit of autonomy, were 16 P-38 Lightnings, modified, refueled, and guided by a plan that had begun not in hangars, but in the code-breaking rooms of Allied intelligence. Operation Vengeance was not just an aerial assassination. It was the pinnacle of modern warfare, coordinated, mathematical, invisible, and fatal. The mission had begun days earlier, when American cryptanalysts intercepted a message in JN-25, the Japanese naval code. The content was unbelievable. Yamamoto was to conduct an inspection visit to the troops on Bougainville, and to do so, it would fly at a known time and route, relying on local air superiority. The decision, made on the basis of doctrinal arrogance that the heavens still belonged to the Empire, proved to be a fatal mistake, because Americans no longer had to guess. They knew. And what followed was a logistical miracle disguised as a military operation. The P-38s departed from the island of Guadalcanal more than 700 nautical miles from the interception point. It was a distance that no fighter at the time, except the Lightning, could cover. But American engineers had adapted the P-38s for this mission. Additional external tanks, fuel mixture adjustment, exhaustive training in compass navigation and timing. Each plane was given an exact flight profile, with specific altitudes and speeds, to cross the ocean in silence, without attracting attention, and reach the point of attack with precision within minutes. The difference between success and failure would be only 30 seconds. Yamamoto's escort flew in a standard formation, 2 Betty bombers, one with the admiral, one with officers, and 6 protection Zeros. The American plan was simple in theory, but brutally complex in execution. Shoot down only Yamamoto's plane without alerting the region's defenses, and flee before any reinforcements could react. At 9:34 a.m., when Japanese radars were still trying to understand what was happening, the P-38s emerged from above at terminal speed in a coordinated attack. The accuracy was absolute. Yamamoto's plane crashed in the jungle. The second Betty was shot down soon after. 3 Zeros tried to fight back, but the Lightnings were already moving up, following the boom and zoom protocol, and disappearing. No mission until then had demanded so much from fighter aviation: extreme autonomy, tactical silence, chronometric calculation, visual identification, and selective elimination. It was not a battle. It was an aerial execution, carried out with surgical precision and unthinkable for the Japanese doctrine, which until that moment still relied on bravery as the main combat differential. The attack was so effective that it took days before the Japanese command confirmed Yamamoto's death. And when he confirmed it, he realized that there was no possible defense against that, because it wasn't just a matter of interception. It was proof that the enemy knew where, when, and how to hit them, with range, with science, with will. The impact of the operation was morally devastating. Yamamoto was not just a commander, he was the strategic brain of the Imperial Navy. His loss created a vacuum, not only of leadership, but of direction. The belief that Japan could conduct a war of attrition evaporated. For the first time, the strategists realized that they were fighting an opponent who saw the entire map, that intercepted messages, calculated flights, and built airplanes for missions that required more than courage. They required mastery of engineering. And here's the cruel contrast. While the P-38s were executing a mission nearly 900 miles from their base, with manual navigation and precise autonomy, Japan was still struggling to get its prototype heavy fighters into operation. They could barely maintain efficient patrols around their own islands, let alone conduct long-range interceptions. The difference in logistical and technical capacity now became unavoidable. Operation Vengeance showed the world, and Japan, that war had changed its era. It was no longer about who had more bravery, more kamikazes, more patriotic slogans. It was about who had the most fuel, the most cryptanalytic intelligence, the most range, and the most accuracy. The P-38, in shooting down Yamamoto, did not just eliminate one man. He eliminated a philosophy of war based on emotion. He replaced it with another, based on data, gears, and cold decisions. In the next part, the symbol of this new era will become even clearer, because the Lightning, designed for air combat, would now begin to be used in ground attack, bomber hunting, and long-range escort missions, roles that required ruggedness, flexibility, and sustained firepower. And while the Japanese were still trying to understand what had happened on Bougainville, the Americans were already preparing the next step, dominating all the skies on all fronts. From 1943 onwards, the Pacific went from being an isolated battlefield to becoming a logistics corridor dominated by silver twin propellers. The P-38 Lightning, previously limited to occasional sorties, was elevated to a new category, not just a fighter, but an air control platform that crossed archipelagos, projected power, and sealed American industrial supremacy over Japan. What made this possible wasn't just the plane's range, it was the colossal infrastructure built to sustain it. Modular air bases, supply convoys, refueling systems, and mobile workshops created an operational web where the P-38 could operate anywhere on the map with assembly line efficiency. While Japan protected its last canisters of fuel with armed soldiers, the Americans fueled fighters with mathematical regularity, as if the war were just an extension of logistics. In the Philippines, the Lightnings made way for the landings. In New Guinea, they operated on makeshift runways, and even there they maintained maintenance standards that guaranteed operating rates above 80%. An astonishing statistic for any twin-engine plane in a tropical environment with extreme humidity. In contrast, the Zeros stationed in the same regions were increasingly immobilized. Basic parts were missing, from magnets to tires. In many cases, Japanese mechanics were forced to cannibalize damaged aircraft to keep one in flight. But even so, performance was poor. The Nakajima engine, without overcompression, could not tolerate altitude, and ammunition depots, increasingly scarce, forced fire restrictions. The fight was a roulette wheel, and the logistics, a failure foretold. The American advance was not only military, he was a mathematician. By 1943, U.S. industry was producing about 7,000 P-38s a year. Japan, in the same period, delivered about 6,000 Zeros, but without significant modernizations, without additional armor, and with a growing drop in assembly quality. The data that most shocked Japanese intelligence analysts was another. For every Lightning shot down in the Pacific, the Americans were able to deliver 3 new ones to the field, fully operational, in less than 3 weeks. An Imperial Navy officer wrote, "They don't just fight with pilots. They fight with ships, factories, and engines that do not stop." And in fact, they did not stop. The Allison V-1710 engine, once considered too complex for the tropical climate, was being maintained with standardized protocols, prepackaged parts, replacement kits that arrived by air. It was a war of support, and Japan was losing on the ground before it was shot down in the sky. Pause for a number that explains everything. In 1944, the American logistics system delivered an average of 1 ton of supplies per soldier per month in the Pacific. Japan, on the other hand, was able to deliver only 150 kilograms per fighter, and this in missions considered a priority. The disparity explains why Japanese hangars emptied, while Americans filled up with new aircraft, spare parts, and high-performance octane fuel. If you were surprised by this abyss, comment below with "Logistics wins," because this was the true secret weapon that brought down entire empires. The P-38 adapted to each new theater of operations. In New Britain, it was used to intercept bombers and cut off aerial refueling lines. In the Solomon Islands, it patrolled with cameras for long-duration photographic missions. In the Marianas, it hunted for reconnaissance aircraft even before they were seen. The versatility was total. And this was only possible because behind every Lightning, there was an ocean of data, parts, maintenance, and fuel that Japan could not even dream of replicating. The engine that powered the American war machine was not just the V-1710. It was the logistical train that came from California, crossed Pearl Harbor, and delivered results on time at the factory. Meanwhile, Japanese pilots, even veterans, faced a cruel dilemma: to fight with planes that could no longer keep pace with the enemy, with rationed fuel, counted ammunition, and zero hope of replacement in the event of a breakdown. A Zero hit hardly returned to combat. A damaged Lightning returned to the hangar, and returned to the sky days later. The difference between the powers is no longer technical. It was structural. The United States had turned the war into a logistical process. Japan still struggled as a tragic art and lost as a repeated play without a stage. By the end of 1944, American intelligence reports showed that the number of operational zeros in the Pacific had dropped by more than 50% in 1 year. At the same time, P-38 squadrons were increasing not only in quantity, but in quality. New variants with more lethal armaments, new radars, and increasingly experienced pilots. The war was no longer balanced. It was an asymmetrical operation. And Japan's defeat had ceased to be a matter of bravery. It was now a matter of time, fuel, and stock. In the next part, we'll look at what happens when even aces stop mattering. Because in the sky taken by P-38s, not even the best Japanese pilot could change fate. Modern war had decreed, it is not man who wins, it's the machine he has behind him. And against the American production line, no single talent would suffice. Japan began the war with a respected air elite. Many of the pilots who flew over China in 1937 were still in the air in 1941, dominating the skies of the Pacific with experience, refined technique, and absolute confidence in their machines. These men formed the invisible core of the doctrine. They not only fought, but taught, corrected, led. They were the living transmitters of knowledge that was not in the manuals, and for Japan, irreplaceable. But modern warfare, waged against machines like the P-38 Lightning, did not recognize veterancy. It only recognized altitude, speed, and range of fire, and these veterans began to fall, one by one. Unlike Germany, which was still able to rotate aces between combat and instruction, Japan did not have a technical reserve capable of sustaining losses. Each downed pilot took with him years of combat, tactical refinement, and most importantly, the flight culture that naval aviation had built before the conflict. And the P-38, with its performance and range advantage, has become the perfect hunter for this elite. It was not just combat, they were aerial executions. On several occasions, Japanese formations were identified and attacked even before they entered the offensive position. By the time they reacted, it was too late. The Lightnings were already back on the roof, ready for another dive. Between 1943 and 1944, the survival rate of veteran pilots dropped dramatically. A post-war study revealed that of the 150 leading figures in Japanese naval aviation who participated in the attack on Pearl Harbor, fewer than 15 were still active at the end of 1944. Most had been shot down, injured, or redirected to non-operational roles, and many of those left alive were simply exhausted. Japan was desperately trying to fill in the gaps, but the training system that took years before the war had now been reduced to months. New pilots arrived at the front with less than 200 hours of flight time, some with less than 100. The impact of this was devastating. Japanese doctrine, based on maneuvered air combat and individual initiative, relied heavily on technical skill and in-flight intuition. But these qualities are not born with a degree, they are forged with time, and that time was over. Faced with American pilots who were already operating according to doctrines of pair combat, a focus on energy, and coordinated use of airspace, the Japanese rookies had no chance, and the P-38, with its terminal velocity and concentrated firing, punished any mistake with impersonal lethality. There was no room for improvisation. It was the era of systematic culling. In September 1944, a Japanese formation of 12 fighters was intercepted by only 4 Lightnings over northern Luzon. In less than 4 minutes, 8 Japanese planes were destroyed. 3 managed to escape damaged, 1 fell on landing, no Americans were shot down. One of the surviving pilots reported, "We didn't know where the shots were coming from. We only saw planes emerging from the sky and then disappearing. They shot and disappeared. There was no fighting." This phrase, so far removed from the doctrinal romanticism that shaped the first years of the war, epitomizes the final collapse of a generation. Because what died there wasn't just a squad. It was a way of seeing the world. With the elite extinct, the backbone of imperial aviation was broken. The squadrons began to operate as dispersed forces without unified command, without cohesion. Many novices were thrown into sacrificial missions without even understanding the limitations of their aircraft. In several cases, the first real flight of these young people was also the last. And with that, Japanese aviation lost its soul. The invisible link between past and present, between technique and tradition, between machine and man. The P-38 didn't just win in the air. He erased the operational memory of an entire force. The side effect of this was silent but irreversible. Without veterans to train and lead, the quality of the units plummeted. Discipline, based rather on example and not just on hierarchy, has lost strength. Coordinated maneuvers have become rare. The spirit of mission dissolved. Many of the new pilots were already entering combat, aware of their own uselessness. They didn't expect to win. They hoped, hopefully, to survive long enough to understand what hit them. The bitter irony is that until 1942, Japan still dreamed of using its air elite as a strategic differential. But by underestimating American spare capacity and by maintaining a doctrine dependent on a few men, he built his own trap. Because the United States didn't just train faster, it trained in volume, with simulators, standardization, tactical analysis, and a culture of debriefing. By 1944, every American pilot was part of a system, each Japanese an island. In the next part, the war enters its most brutal stage, because now the P-38 will not only be used as a fighter, but as a scout, escort, and executor for B-24 and B-25 bombers. The sky will no longer be a dueling arena. It will become a corridor of coordinated destruction, where each silver lightning bolt drives a much larger storm. And for Japan, what comes next will no longer be combat. It will be survival. In 1940, the Mitsubishi A6M-0 was considered a masterpiece. Light, maneuverable, and with extended reach, it surprised the world by dominating the skies in the early years of the war. But what began as an engineering triumph would soon turn into a technical prison. Zero was conceived within a rigid industrial structure, with scarce resources and a closed mindset. Unlike the Allies, who treated their designs as living organisms, mutable, upgradable, iterative, Japan froze its fighter in time. Zero's own glory became his greatest enemy. It was an airplane that, in the Japanese institutional view, did not need to change. And this mistake would be costly. The Zero's frame was based on a lightweight aluminum alloy called extra superduralumin, designed to sacrifice strength in exchange for lightness. This gave the fighter an advantage in maneuverability, but made it extremely vulnerable to damage. Throughout the war, when armor became standard and self-sealing tanks became a necessity, Japan hesitated. Changing the structure would imply complete re-engineering of the cell, reworking production, and above all, admitting that the original design had flaws. In a military culture that punished doubt as weakness, hesitation became state policy. Meanwhile, in the United States, the P-38 Lightning was continually redesigned and tested. Since its first operational version, the fighter has undergone a series of updates, each guided by field data and technical analysis. Hydraulic ailerons were introduced to improve control at high speeds. The compression of the engines has been adjusted for better altitude performance. Cooling systems have been modified for tropical flights. And in the final versions, some units were even equipped with radar, allowing night missions and interception beyond visual range. It wasn't a perfect fighter, but it was a fighter that learned, that he adapted, and that every month became more difficult to face. The Zero, on the other hand, remained largely the same until the last months of the war. Attempts at modernization, such as the A6M5 and A6M8, came too late or never reached significant production. Japan simply did not have more powerful engines. Most factories were isolated, laboratories suffered from resource cuts, and the supply chain was fragmented. A fighter with higher performance would require more fuel, more spare parts, more specialized labor. But all this was scarce. Instead of revolutionizing, they chose to conserve. Instead of evolving, they insisted, and heaven has not forgiven that choice. The P-38 also benefited from a test ecosystem. The Americans had advanced wind tunnels, proving grounds, teams of engineers deployed exclusively for combat performance analysis. When a pilot reported a failure, that information was processed, catalogued, and turned into action. In Japan, reports from the field were often ignored or filtered out by senior officers who were afraid to suggest any criticism of the central project. Institutional verticality has turned technical feedback into heresy. Doctrine stifled engineering, and the result was a fighter that, although still lethal in the hands of veterans, became irrelevant in the face of the new reality. Zero's lack of modernization also directly impacted its lethality. While the P-38s received high-rate centralized armaments, such as 4 50 machine guns and a 20mm cannon in the nose, ensuring absolute accuracy, the Zero continued to operate with 2 synchronized light machine guns and 2 cannons with limited ammunition. In combat, this meant less impact, less fire time, and more reliance on surgical hits. Against heavy bombers and armored fighters, it was an unsolvable tactical problem. It was not enough to hit, it was necessary to penetrate. And Zero no longer had anything to do with it. More than a technical problem, Zero's stagnation revealed an institutional collapse. The Japanese Navy had made the fighter a national symbol, untouchable, perfect, heroic. Any attempt to alter it was seen as a symbolic threat, not a technical necessity. Meanwhile, in the United States, pragmatism was absolute. What worked was maintained. What failed was corrected. There was no pride in resisting change. There was merit in embracing it. The starkest contrast between these philosophies is revealed in a single figure. Between 1941 and 1945, the United States produced more than 140 operational variants of fighters, taking into account adaptations, field modifications, and redesignations. Japan, in the same period, introduced fewer than 25 real variants, and most of them without significant structural changes. If you were surprised by this difference, comment below with "Evolution is a weapon," because in this war, adapting was as lethal as shooting. The P-38 did not beat the Zero by chance. He won because it was a living project, fed by data, tuned by engineers, maintained by technicians, and driven by an industry that understood war as a process, not a dogma. Zero, frozen in 1940s glory, became a ghost of itself, a plane that impressed the world, and then was surpassed by it. In the next part, we will look at what happens when the enemy not only wins technologically, but also morally, because the collapse of Zero was not only physical, it was symbolic, and Japanese pilots, who once believed they were invincible, now prepared for missions of no return, not because they wanted to die, but because they no longer saw how to win. At the beginning of the war, the sky was the stage. Air combat still carried the echo of the chivalric duels of the First World War, maneuvers in a circle, mastery of the rear position, close turns, a deadly dance where the most skillful, and not necessarily the most equipped, prevailed. It was against this backdrop that Japanese doctrine had been forged. Its pilots were trained extensively in turning tactics, visual coordination, and individual attack. The Zero, light and agile, was the physical extension of this philosophy, made for dogfighting. But the P-38 Lightning, upon reaching the skies of the Pacific, completely ignored these rules. It didn't rotate. He dived. And in doing so, he destroyed more than fighter jets. He dismantled an entire doctrine. The technical irony was brutal. The more the Japanese pilot sought the maneuver, the more vulnerable he became to the American style of combat. The boom and zoom, the attack at speed from altitude, followed by quick escape before any reaction. It was a mathematical logic, almost cold, where there was no room for spontaneous bravery. The American pilots operated in pairs with interdependent functions. One attacked, the other covered, and everything was coordinated by radio. There were no more lone heroes. There were real-time decision systems supported by technical and logistical superiority. Meanwhile, on the Japanese side, radio was still limited in range, clarity, and discipline of use. Many squadrons operated in silence, relying solely on vision and intuition. The result? Tactical confusion, disorganization in combat, coverage failures, and the repetition of fatal mistakes. In combat recorded in 1943 and 1944, it was common to see scattered Japanese formations attacking different targets with no protected rear. The Americans, on the other hand, when they identified flaws in the attack pattern, adapted protocols, instructed by footage from cameras installed in the wings, which recorded every second of the fighting. These cameras were not just for propaganda, they were pedagogical tools. After each mission, the P-38 pilots reviewed their mistakes, studied the enemy's movements, and identified positioning flaws. It was an aviation that learned, that evolved with each flight. Japan, without this apparatus, relied on oral accounts and memory. In an increasingly data-driven war, this was a structural backwardness, and the result was visible. Japanese tactics became predictable. In each new engagement, the Americans knew what to expect: turn dives, frontal assaults, or attempted engagement in horizontal turns. Against the Zero of 1940, this worked. Against the P-38 of 1944, it was suicide. The Lightning could rise while the Zero stalled. He could dive without risk of structural bankruptcy. It could fire with concentration of fire without worrying about the convergence of machine guns. It was a weapon from another era, an era that Japan still refused to recognize. American aviation was not only superior in the sky, he was superior on the ground. Mobile workshops accompanied the squadrons. Engineers could modify settings depending on the environment. Fuel tanks, ammunition, spare parts, everything was delivered with surgical precision. The Japanese, on the other hand, operated with limited stocks, worn-out engines, and in many cases with pilots who flew, knowing that there would be no spare parts in case something failed. It was a war between a force that functioned as a network and another that resisted as an archipelago. And perhaps the most symbolic point of this collision between doctrines was the absence of adaptation. Even in the face of mounting losses, Japanese instruction continued to emphasize the same techniques. They continued to train for the spin, for the duel, for the head-on encounter. The Americans, on the other hand, had abolished protracted combat. Each mission was built to be brief, coordinated, and lethal. Imperial aviation trained soldiers, the American system operators, and in the end, the system always beats the isolated hero. The irony of this story is that the solution was in front of them. It was enough to change the paradigm. It was enough to understand that courage does not compensate for altitude, that spins are no substitute for compression, that honor does not protect from concentrated bullets. But change requires rupture, and rupture requires structure. Japan had neither. If you're enjoying unraveling these facts in depth, show your support, like the video, and subscribe to the channel. It is with this support that we can continue to produce content that is detailed, respectful, and technically faithful to the complexity of the story. In the next part, we will find out what happens when an air empire, already technically and morally defeated, decides to exchange doctrine for martyrdom. because the next stage of the war in the skies of the Pacific will no longer be about maneuvering. It will be about missions of no return. And in this new theater, the P-38 will not only face fighter jets, he will face pilots who were already taking off dead. The P-38 Lightning did not fly alone. Each takeoff that tore through the skies of the Pacific was supported by an invisible but absolutely lethal gear: American infrastructure. The Allies' real weapon was not just the twin-tailed fighter, but the system that powered it, a logistical network that began in factories in the interior of the United States, crossed oceans in protected convoys, and ended up on makeshift airstrips on the most remote islands in the Pacific. While Japan bet on the pilot as the central point of the air war, the United States bet on structure as a decisive factor. And it was this structure that the Japanese did not see coming. In the field, this translated into efficiency. The P-38 could be kept operational with impressive speed, mobile workshops, standardization of parts, accurate technical manuals, specialized mechanical training. All this allowed the fighter to be in the air day after day, mission after mission, without relying on improvisation or sacrifice. It was a technical chain at the service of continuity. On the other hand, the Japanese faced breakdown after breakdown. Engines with extreme wear, parts that did not arrive, bombed hangars and, in many cases, runways without the minimum conditions for prolonged operations. This disparity was widened by the most invisible factor of all: radar. By 1943, the Americans were already operating onboard radar on night missions and using ground stations to coordinate intercepts and guide squadrons by radio navigation. This meant that an American pilot could take off from a hidden base, fly hundreds of miles over the ocean, attack a target with precision, and return with electronic assistance. The Japanese, by contrast, relied almost exclusively on visual navigation and geographical references, a risky technique in a theater of war composed mostly of open seas and tiny islands. American logistics didn't just sustain the fighters, it anticipated their needs. High-octane fuel was delivered regularly. Standardized ammunition facilitated quick refueling, and the use of transport such as the C-47 Dakota kept supplies flowing continuously between newly built bases. Each new American runway came with underground storage, pressurized refueling points, and even drainage systems to allow operations even in tropical rain. These were technical details that guaranteed air supremacy not by direct combat, but by constancy. The structural irony was total. Zero was created as an instrument of individual excellence, but the P-38 was the spearhead of an impersonal, industrial, standardized system, one that learned, corrected, and advanced. When one P-38 was shot down, another was ready to take its place. When a Zero crashed, there was no immediate replacement because there were no parts, no pilots, no revised doctrine. Every week, Japan sank deeper into its own basic limitation. It was not possible to win an industrial war with faith in the spirit when the enemy operated like a machine. It is important to note that this system also thought about the post-combat. The Americans recorded all the missions, analyzed failure patterns, calculated average flight time, parts consumption, and structural wear. Even the landing was optimized. Strips of grass, reinforced with metal tracks, allowed the P-38 to land in places previously considered inoperable. The war had become an equation, and the United States had all the data. This infrastructure didn't just sustain the combat, it multiplied the combat. While a Japanese squadron could operate with 4 or 5 aircraft in real flight conditions, the Americans launched sorties with 30, 40, 50 fighters at regular intervals. The difference was not just one of quantity, it was rhythm. Japan played chess in slow motion with fragile pieces. The US played aerial blitzkrieg with interchangeable pieces. And in this game, time was the first weapon. Japan knew this. Japanese officials wrote after the war that the war was taken out of the air by a factory, not by a pilot. A belated acknowledgement that the P-38 was just what was seen. The rest was what sustained. An iceberg of production, science, and coordination. A chain where each link was designed to last and adapt. And this is what explains how, even with natural war losses, the Americans maintained availability rates above 80%, a statistic that, for Japan, was unthinkable. If this complexity surprises you, it's worth remembering we're only seeing the surface, because the next chapter will not be about parts, radars, or fuels. It will be about the final rupture, the moment when Japan, without resources, without veteran pilots, and without equivalent aircraft, decides to bet everything on a single asset that remained: human sacrifice. In the next part, we'll cross the line between technology and despair, where doctrine no longer seeks victory, but meaning. Because when the P-38 started shooting down planes piloted by men who knew they wouldn't come back, heaven is no longer a battlefield and has become a silent altar of farewells. In 1944, the sound of Zero cutting through the skies of the Pacific no longer aroused fear. It was, increasingly, the sound of insistence on an era that had ended. While the P-38 Lightning continued to dominate the skies with precision and technological superiority, the legendary Japanese fighter, once feared for its agility and range, had become irrelevant on the battlefield. Air battles ceased to be combats between equals and became technical executions. The Zero no longer kept up in altitude, speed, or firepower. In military terms, it had become a target, not a threat. The degradation was slow, but inevitable. Japan, without industrial reserves and with collapsing logistics chains, could no longer adequately fuel its planes. The fuel was increasingly adulterated, with a lower octane rating and a high risk of flight failures. The engines, overloaded and poorly cooled, burned before completing missions. In response to the shortage, old units were refurbished with improvised, repurposed, or incompatible parts. By 1945, there were Zeros taking off with less than 30% of the performance they had in 1941. Meanwhile, the Americans launched improved versions of the P-38, with improvements in ailerons, propellers, cooling, and even onboard radar systems. A chasm of innovation separated the two sides, and Japan no longer had a bridge to cross it. But the most brutal dimension of this obsolescence was symbolic. The Zero wasn't just an airplane, it was a myth. It was the pride of Japanese engineering, the icon of lightning victories at Pearl Harbor, the Philippines, and Malaya. Each pilot was taught to see it as an extension of his own body. And now, that body was slow, fragile, and outdated. The veterans themselves began to notice. We flew as if we were in 1940, but the enemy was already in 1950. Letters from pilots show growing frustration, quiet shame, and the feeling that they were being sent to die on machines that no longer corresponded to the actual war. Some tried to resist. Squadrons were repositioned, tactics revised, late versions of the Zero received minor modifications. But no intervention was enough. The P-38 operated at altitudes where the Zero barely reached. It arrived too fast, left too early, and fired from distances where the Zero did not even visually identify the enemy. Air combat, once defined by skill and proximity, had become a matter of sensors, energy, and calculation. The Zero, shaped for a war that required maneuvering, was now hunted by a war that required range. On bombing missions over Japan, the P-38s began to act as long-range escorts, opening clear corridors for B-29 formations. On several of these missions, Japanese fighters could not even reach the bombers. When they did, they were shot down before reaching effective range. A 1945 American report stated that the threat of Zero had been statistically nullified. It was no longer about defeating the enemy. It was about ignoring him. Zero had ceased to be a variable. This strategic erasure had a devastating moral effect. The pilots knew they were fighting for honor, not effectiveness. And they knew, too, that on the other side were men who did not fly for glory, but for instruction, for planning, and for a logistical machine that sustained them. It was the victory of production over improvisation, of calculation over courage. A silent but irreversible victory. By the end of the war, many Zeros could no longer fly. They were stopped in improvised hangars without parts, without fuel, without qualified pilots. They were relics of a time when courage was enough. But now, heaven demanded more. It required operational altitude, integrated systems, predictable engineering, and make-up chains. Japan bet everything on exceptional men. The United States has bet on exceptional systems, and the system won. In the next part, we will dive into one of the most symbolic and tragic chapters of this transformation, when the Japanese doctrine, already technically defeated, decided to abandon conventional combat and chose to turn its own body into a weapon. The fighters stopped taking off to fight. They started taking off to die, and when the P-38 began to face planes that no longer intended to return, the duel ceased to be technical. It became a ritual of sacrifice, despair, and goodbye. Years after the last dogfight over the Pacific, when the roar of the engines died down and Japan bowed to the brutal evidence of defeat, voices began to emerge, not of the victors, but of those who survived the ruin. Veteran Japanese pilots, such as Saburo Sakai, began to give testimonies that, at the time of the war, would have been unthinkable. It was not just a matter of acknowledging the enemy's technical superiority, but of a deeper, more painful confession that they had fought a war with the wrong tools, spiritual, doctrinal, and industrial. Sakai, who flew more than 200 missions, described the P-38 as a ghost with two tails, impossible to face, impossible to forget. But what marked him most, he said, was not the machine itself. It was the system that kept it flying, that improved it, that replaced it without pause. It was war as a process, not as a duel. Other survivors reported similar feelings. Some said that when they saw the P-38s rising toward the Japanese formations, they no longer felt the strain of combat. They felt resignation. It was like watching the tide rise. They could try to resist, but they knew they were facing something inevitable, impersonal, unstoppable. One former driver reported, "It wasn't cowardice, it was calculation. They didn't come to fight. They came to close the equation." This realization destroyed what was left of Japanese confidence in the doctrine of the individual warrior. On the contrary, it elevated the concept of the system as a true dominant force. Bravery had become obsolete. This awareness generated two distinct reactions. One was moral humiliation, the collapse of national pride. Many pilots fell silent after the war, refusing to speak for decades. Others, however, have converted this lesson into transformation. It is not by chance that several of the engineers and former officers of Japanese aviation became part of the technical staff of the Japanese reconstruction in the following years. They knew they had lost not because of a lack of courage, but because of a lack of adaptation. And it was this realization that fueled the new Japan, a nation that, in the 1950s and 60s, replaced the samurai ideal with technical obsession, meticulous engineering, factory efficiency. It was the war, ironically, that taught them to win without fighting. A curious fact emerges in this period. Many of the former pilots began to study American aviation in depth. Some even wrote manuals about the P-38, not to glorify it, but to understand how a seemingly brutish and clumsy aircraft had become an icon of strategic victory. They discovered, with some astonishment, that the P-38 was not the best plane in all respects, but it was the most complete. It flew high, shot far, returned to base, and it did so with the support of an ecosystem that foresaw failures, created solutions, and prevented chance from deciding fate. The real adversary, they realized, was not the pilot of the P-38. It was the system that put him there. It is at this point that the legacy becomes a historical lesson. Japan in the 1940s believed that war was an extension of character, that victory was born of the purity of ideals. But modern warfare did not respect intentions. It responded to mathematics, engineering, production, logistics. It was a war where planning defeated passion. And this culture shock was, perhaps, the most profound of all. The defeat did not come only from heaven, it came from the silent dismantling of a worldview. By the end of the war, more than 12,000 P-38s had been produced. The Zero, on the other hand, even with its legendary aura, was manufactured in inferior numbers and with less and less quality. The aviation war, which began as a duel between wings and pilots, ended as an equation between steel, fuel, strategy, and aftermarket. And the Japanese, through the mouths of their own surviving aces, admitted they lost not in combat, but in concept. And here the inevitable question arises: what is left for the warrior when his battlefield is replaced by a laboratory? When your courage is defeated by a production sheet? When the sound of your machine is swallowed up by the muffled hum of an enemy that no longer fights, only wins? The answer lies not in the statistics of the war, but in the faces of those who returned. Men who came out of the cockpit to the factories, from the clouds to the projects, and who learned with great difficulty that the age of the sword was over, and that the new war would not be won with sacrifice, but with precision. In the next and final part, we'll look at how this story ends, not with explosions or glorious victories, but with silence, the silence that comes after destruction. Let's understand what the P-38 symbolizes to this day, and why its dual tail is not just a design trait, but the mark of a historic turning point. When bravery met the limit of physics and war ceased to be a matter of courage, to a matter of calculation. When Japanese pilots realized they could no longer climb, escape, or even visualize the enemy, it wasn't just a tactical defeat, it was the silent collapse of a world view. The P-38 Lightning, with its supercharged turbines, its range of thousands of kilometers, and its accuracy of attack at unreachable altitudes, was not just a war machine. It represented the arrival of a new time, a time when courage was not enough, honor did not protect, and maneuverability did not win. Zero, the pride of the empire, had been designed for a war that no longer existed, and the P-38 was the messenger of this obsolescence. Across the Pacific, twin-tailed fighters didn't just shoot down aircraft, they disintegrated doctrines, burned outdated codes of war, and turned the sky into engineering territory. American victory was not achieved with isolated acts of bravery, but with applied mathematics, factories operating day and night, standardized parts crossing oceans, and pilots guided by systems that functioned as an extension of the machine. It was not a war between planes. It was a war between eras. This story carries a lesson that goes beyond aviation. Modern wars are not only won on the battlefield, they are won in engineering projects, on assembly lines, in the silent logistics that supply and sustain. The myth of the lone warrior has given way to the strength of the integrated system. Tactics can win battles, but only sustained production wins campaigns. The P-38 taught that range, autonomy, coordination, and maintenance are worth more than the tight turn of a turn. And most importantly, he taught that no doctrine, no matter how honorable it may seem, survives the physics of modernity. Bravery alone is noble, but it is not enough. Who admitted this with disconcerting clarity was General Adolf Galland, a veteran of the Luftwaffe, when reflecting on his own defeat. We were outclassed not by pilots, but by production. We were defeated by trucks. This phrase, coming from one of the greatest aces of the Axis, synthesizes all the irony and depth of this series of battles. The Pacific Air War wasn't just a duel in the sky, it was the ultimate judgment of adaptability, and the verdict was ruthless. If this narrative brought new data, if it helped you understand how history folds in the face of logistics, leave your like and subscribe. This helps our channel continue this mission of rescuing the truth based on documents, engineering, and testimonies. Write in the comments, what was the most shocking data you discovered in this video? And ring the bell, because the next story will reveal another devastating detail that changed the course of the war and almost no one knows about. Don't go away yet. Listen to the next true story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.